Now, in this lecture, we will find the values of x and y. We have a shape. The area of this shape is 240 units squared. The width of the shape is 15 units, and the length of this y shape equals to 20 units, and we want to find out the value of x and y. First of all, we will give names to the vertices of this shape. We will define this vertex as A. We will define this vertex as L. We will define this vertex as C, and we will define this vertex as D. Okay, in the next step, we will extend the line segment X to a size of 20 units. And then we will lower perpendicular from this point to line segment CD. So I repeat again what I did. First of all, I extended line segment X to a size of 20 units, and then from this point I lowered perpendicular to line segment CD. So actually this angle is a right angle, it equals to 90 degrees. And this angle is also 90 degrees. And we have already know that this is a right angle, angle CAL is a right angle, and also angle DCA is a right angle. So actually we created a rectangle. I will define this point, this vertex as B. Actually, shape ABCD is a rectangle because of the fact that AC is parallel to BD, and AC also equals to BD. This is 15 units, BD equals to 15 units, and also AB equals to CD equals to 20 units, and also AB is parallel to CD. For that reason, the shape ABCD is a rectangle. Okay, because in a rectangle you have two sides that are equal to each other and also parallel to each other, and also the other two sides are also equal to each other and parallel to each other. And this shape ABCD satisfies the definition of a rectangle. For that reason, ABCD is a rectangle, and the area of any rectangle is actually the formula for the area of a rectangle is actually the length of the rectangle times the width of the rectangle is the area of a rectangle. So the length of a rectangle times the width equals to the area of a rectangle. So the formula for the area of a rectangle is the length of the rectangle times the width of the rectangle. Okay, so the area of rectangle ABCD equals to the length of the rectangle, that is 20 units, times the width of the rectangle, that is 15 units, so the area of rectangle ABCD will be equal to 300 units squared. So the area of rectangle ABCD equals to the length of the rectangle, that is 20 units, times the width of the rectangle, that is 15 units. So 20 times 15 equals to 3 units squared. So the area of rectangle ABCD equals to 300 units squared. I made a mistake. I said 3, but I meant to say the area of rectangle ABCD equals to 300 units squared, because it is the length, that is 20, times the width, that is 15. 20 times 15 is 300, so the area of rectangle ABCD equals to 300 units squared. Okay. So what is the area of the right triangle LBD? The right green triangle LBD. What is the area of this right green triangle? The area of this green right triangle equals to the area of the rectangle, that is 300 units squared, minus the area of the shape ALCD, that is 240 units squared. So the area of the green right triangle equals to 300 minus 240, that is to say 60 units squared. Okay, again the area of the green triangle equals to the area of the rectangle, that is 300 units squared, minus the area of shape ALCD, that is 240 units squared, is given us. So 300 minus 240 equals to 60 units squared. So the area of the green right triangle, triangle LBD, equals to 60 units squared. Okay, the area of the green triangle is 60 units squared. It is the area of the rectangle minus the area of the white shape. So it is 300 minus 240, it equals to 60 units squared. Okay, so now I will draw again the green right triangle LBD. Actually, the size of LB equals to 20 units minus x. Again, the size of side LB of the right green triangle equals to 20 units minus x. So I draw again the right triangle LBD. Actually, we can use the formula for the area of a triangle in order to find out the value of x. And the formula for the area of any triangle is actually the base of the triangle times the height to the base over 2. Okay, so the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. You should remember that the height to the base must create 90 units with the base. Okay, so the area of this right triangle will be equal to the base of the triangle that is 20 minus x times the height to the base. The height is 15 units because BD, side BD creates 90 units with LB. BD is perpendicular to LB, so the height of this right triangle is 15 units because it creates 90 units with the base. So it is 20 minus 6, the base times the height, that is 15 over 2. Okay. So the area of the right triangle equals to the base of the triangle, that is 20 minus x, times the height, that is 15, over 2. But we know that the area equals to 60 units, so we can substitute the area of triangle LBD by 60 units squared. We substituted the area of triangle LBD by 60 because it is equals to 60 units squared. Here we can multiply the equation number 1 by 2. So we multiply the equation number 1 by 2. 60 times 2 is 120, and 20 minus x times 15 times 2 divided by 2 is 20 minus x times 15. We will open the brackets in the first equation. So we opened the brackets in the first equation. 20 times 15 equals to 300, and x times 15 equals to 15x. So we got that 120 equals to 300 minus 15x. Now we'll subtract 120 from equation number 1. So we subtracted 120 from this equation. 120 minus 120 equals to 0, and 300 minus 120 equals to 180. So we got in total that 0 equals to 120 minus 15x. Now we will add 15x to this equation. So we added 15x to this equation. 0 plus 15x is 15x, and 180 minus 15x plus 15x equals to 180. We'll divide this equation by 15. So we divided this equation by 15. 180 over 15 equals to 12 units. So x equals to 12 units. So we know that x equals to 12 units, so 20 minus x is 20 minus 12 equals to 8. 20 minus 12 equals to 8. So in this right triangle, we know that DB equals to 15 units, LB equals to 8 units, and we will use the Pythagorean theorem in order to find out the value of y. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is y squared equals to the sum of the squares of the perpendiculars equals to 15 square plus 8 square. Okay, we got that y square equals to 15 square plus 8 square. 15 square is 225 and 8 square is 64, so I write it down. Okay, we got that y square equals to 225 plus 64. 225 plus 64 equals to 289, so I will write it down. Okay, we got that y square equals to 289. Now we will take a root out of equation number 3. So the root of 289 is 17. So y equals to 17 units, and we've already found out that x equals to 12 units. Okay, so the answer to the question is that y equals to 12 units, y equals to 17 units, and x equals to 12 units. Okay, now I will summarize the lecture. Actually, the question was to find out the value of x and y in this right shape, in shape ALCD. We know that the width of the shape is 15 units and the length of this shape is 20 units, and we want to find out the value of x and y. And we also know that the area of this white shape equals to 240 units squared. Okay, so in order to find out the value of x and y, I extended line segment x to a size of 20 units, and then I lowered perpendicular from point B to line segment CD here. Okay, so in this way I created a rectangle. ABCD is a rectangle, and we know that the formula for the area of a rectangle is the length of the rectangle times the width of the rectangle equals to the area of the rectangle. So the area of this rectangle will be equal to 15 to 20 times 15. 20 is the length times the width. The width is 15 units. So the area of this rectangle equals to 300 units squared. And the area of the green triangle will be equal to the area of the rectangle minus the area of this right shape. So the area of the rectangle equals to 300 units squared minus 240 units squared. That is to say, the area of this green right triangle equals to 60 units squared. Okay, I copied the right triangle again. I copied it here. I draw it here. And we know that the area of this rectangle equals to 60 units squared. This side equals to 15 units, and this side is actually LB, and LB equals to 20 units minus X. Okay, LB equals to 20 units minus X. Actually, the only missing variable here is X. We know that the area of this right triangle equals to 60 units squared. So the formula for the area of any triangle is actually the base of the triangle times the height to the base over 2. Okay, so the base of the triangle is 20 minus X times the height is 15 over 2. Okay, so that is the formula for the area, the base 20 minus X times 15 over 2. But we know that the area equals to 60 units squared, so we can substitute the area of triangle LBD by 60, because it is equal to 60 units squared. We substituted it by 60 and we got this simple equation with only one variable. We solved that equation and we found out that the value of X is 12 units. The value of X in this white shape equals to 12 units. After we know that X equals to 12 units, we actually can we actually know the size of LB, because the size of LB equals to 20 minus X, and X equals to 12. So 20 minus X, that is 12, equals to 8 units. Okay, so in this right triangle we know that this side equals to 15 units, this side equals to 8 units, and the only missing variable is the hypotenuse of this right triangle, so we can use the Pythagorean theorem in order to find out the value of the hypotenuse. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, y square equals to 15 square plus 8 square. Okay? And we actually have this one. We implemented the Pythagorean theorem in the right triangle. Y square equals to 15 square plus 8 square. We solved this equation and we found out that y equals to 17 units. So the answer to the question is that y equals to 17 units and x equals to 12 units. Okay, thank you very much.